Good morning all, it's new, it's brand new, it's the iSDT T8. In fact, it's so new that it's not actually yet on iSDT's website. Here's the list of their products, and no, the T8 isn't there. So I'm sure it'll appear there soon, but yes, it seems to be hot off the production line. So let's have a little unboxing and see what's inside. And there is a little manual, but it's very brief. There's a screen protector here which you can apply to the front of the unit if you want to protect the screen. There are some stickers, and there's the iSDT T8, which is a BattGo smart charger. It's not in pristine condition because I admit I have been playing with this a bit. BattGo is this new extra wire which is applied to the XT60 connector. There's the extra connector. It's a little copper line where the little indent normally is, and that means that the charger can actually read information from the battery. Right, let's have a look at this user guide, which is actually very brief. In fact, it says 1. Connect to power, wait for completion of self-test. 2. Through the multifunction keys and input keys to set the charging parameters for your battery. 3. Enjoy your T8. Yes, that's very brief. And on the iSDT website download page, of course, there's no operating instructions yet for the T8, so I'm going to have to work this out for myself. There is some information on Banggood's website. In fact, here it is. There's some specification, lots of these product photos, which Banggood tend to do. They tend to put a lot of information, all the visual information they can. So we got some stuff on the fully supporting the BattGo standard, which is this third wire on the XT60 connector. We've got a nice picture of the circuit board and the layout. High density fin radiator. There's the heatsink there, and then there's a fan at the back. High cooling efficiency. Complete over temperature, is that? Over current, over voltage, over load, and reverse polarity protection, and an anti-spark function. We've got unexceptionable performance. Unexceptionable, is that a word? Unexceptionable. Yeah, well, it seems that unexceptionable is a word.
Unexceptionable.
Oh, that sounds like Gadget Addict. Not open to objection, but not particularly new or exciting. That's a really strange choice of word. Anyway, unexceptionable, presumably meaning it can't be beaten. Performance on the power space ratio, 2,400 watts per litre, whereas competing products have a 601, and another odd number, watts per litre density of sort of power to the volumetric size of the charger, I suppose is what they're getting at. Here are some screens. We can see here that we've got cell impedances, cell voltages in the charging mode, and cell voltages in the charge done mode. And there's some spec, and this spec is really interesting. It's also here on the back of the unit. It says input voltage is 12 to 40 volts, DC that would be. Maximum input current 35 amps, maximum output current 30 amps, and maximum output power 1,000 watts, 1 kilowatt. Hard to believe from this little unit, but that would be what, 30 amps at about 36 volts or something like that to give that 1,000 watt rating. Right, in terms of size, this unit is about, oh, you can't really read that. Well, it's about the size, I suppose, of about half a grapefruit. Yeah, that would be about right, half a grapefruit. Which, for its size, does make this 1,000 watt rating all the more impressive. Right, let's look at switches and connectors. We've got a 4-way multifunction switch here. Now, I seem to remember from that photo of the PCB that it just had 5 tactile switches underneath there. So you've got 4 and the center one. We've got the output DC connector there, which is XT60i with the extra pin. We've got a 9-pin connector there because this unit can take packs up to 8 cells in series, 8S, that's why it's called the T8. And here on the other side we've got the input XT60i connector. There's a connector here which I think is a 3.5mm jack, which is used for firmware upgrades. You do have to buy iSDT's special adapter for that. And here there's a USB output, I think just for charging phones, but without much in the way of details. I don't quite know what that is. I think it said 2.1 amps on Banggood's website. So this unit has been very kindly supplied by Banggood.com. So thanks very much to Banggood. And I will put a link to this item on Banggood's website in the description below the video. It is a sales tracking link. So Banggood are watching how many people click through on that link from this video. Right, as this very brief manual said, connect an input power source and enjoy your T8. Well, okay then. So I'm going to connect this with an XT60. This is not XT60i. This is not a BattGo battery. I do have a couple of BattGo batteries coming because I want to see what other facilities these iSDT units provide when you do have that extra pin. But let's plug this in and see what happens. And it goes beep beep and does a fan test. Now it's showing me cell voltages. I'm going to change the light level a bit so that this screen is more visible. Right, cell voltages or cells voltage. There is no cell voltage information because that will come from the battery being charged. This is my supply battery, the power source for the charger. This is a DC charger. There's no AC connector on here. This little line here means that there's another screen to look at. So if I scroll down, we can look at that. It tells me that the input voltage, that's the input symbol, is 14.9 volts. That's coming from this 4-cell Lipo. The internal temperature of the unit is 21 degrees C, and 0 pieces and 9 pieces, I think something like the number of batteries it's charged in its lifetime, something like that. So let's go back to this cell voltages screen and get to this other Lipo, which is an 11.1 volt 3-cell pack, as we can see there. This one's oddly got a JST power connector on it, but I've got an extension here for XT60. Now the other XT60 is the other way round, so let's plug that in, and we can immediately see that it's displaying the voltage. Then if I connect the balance port, minus is indicated on that connector, so that's nice and easy. Go for the black wire on there, connect that in there, and immediately the cell voltages 3.78 and 3.79 on that third cell become visible. Now what happens if I disconnect the main power connector? Nothing really. It's now measuring the total voltage of the pack via that balance connector, so it doesn't seem to really matter whether that main connector's on or not, although of course during charging it will require that main connector. Right, from this front screen I can press the center button and it takes me to task settings. Now I want to do well, let's do a discharge of this because I want to see how the cooling system in this unit works. So let's go up, press enter for that and go to discharge. We're going to discharge at the maximum current, which is 5 amps. No, I can't go any further than that. So 5 amps. Cell count is 3S. Well, let's lie and tell it that it's actually a 4S, like so. And I want to discharge down to 3.3 volts. Now you can discharge to other voltages. It has a selection from 3.2 up to 3.4, but 3.3 has this sort of thumbs up symbol by it. So that's obviously the recommended voltage to discharge to. So there we go. It's a Lipo, 3.3 volts. I'm telling it it's a 4S, even though it's not, it's a 3S. And I want to discharge at 5 amps. Let's start that going. Now the first thing you'll see is that actually it's changed the 4S that I set to 3S. So it's reasonably intelligent. It doesn't like you lying to it. It said, no mate, it's not a 4S, it's a 3S. So it's just automatically done that for me, which is very good. because if you make an error, it just sorts it out for you. Right, okay, so we can see the cell voltages on this pink screen. This is the discharging screen. We're discharging at minus 0.9 amps. Now, I seem to remember I set this to 5 amps, and that's quite interesting. If we look at the next screen, you can see that the input voltage is 14.9. That's coming from this input pack, and that's only drawing 1 watt. It's only enough power to power the electronics and this display, so it's not really drawing much from this at all. The discharge power ratings are 10 watts. Now, I've worked out that 10 watts is on this main connector, and in fact, if you multiply 0.9 amps by about 11.1 volts, that's where that 10 watts comes from. But it's also consuming 15 watts from the balance lead or line or the BL. So it's taking 5 watts per cell also are going into that heatsink. And you might be able to see here that the temperature, the internal temperature, is now creeping up, 36 degrees. So where do they get this 5 amp discharge from? Well, I reckon it's from the 10 watts or 1 amp it's doing. And if this was an 8 cell pack at 5 watts per cell, now I've got to work this out, haven't I? That would be 5/8 are 40 watts with about 11 volts. What's that? Well, it's not a million miles away from another 4 amps. So I think what they're saying is you can put an amp out through the main connector and then a fair bit more, depending on the number of cells, out through the balance lead connector. I think that's what it's getting at. Right, I'm just waiting for this temperature to get up to the trigger point where the fan comes on, which is 60 degrees. Right, while we're waiting for that temperature to get up to the point where the fan comes on, we can look at the other screen in this discharging mode, which of course just gives me the cell voltages. Now I assume it's doing a balanced discharge. In fact, let's just pull this out. Okay, well, it says discharge done, so it got a bit cross. Now, will it discharge this? So discharge 5 amps, 3 cell Lipo to 3.3 volts. It will, but it says perform task without balancer. Yeah, okay. So yes, it will do a discharge. Of course, there's no other screen here because there's no cell voltages to look at. So all it's looking at is the overall pack voltage. But yes, it will do a discharge without the balance connector. It just does it through the main connector. And you can see here now that it's only showing 10 watts of discharge. Let's plug the balance connector back in. Of course, I'm doing this all with the power on and the thing running just to see if it can handle all of that. Okay, so it says discharge done, so we need to run that again. And of course, that's as we were before. This is doing a discharge now, and I presume it's also balancing as it discharges. In the Banggood listing, it said that the current per cell for discharging is 2.2 amps, I think it was. Yeah, so here it is, balancing current 2.2 amps per cell. Now, of course, it's during discharging a pack where the unit gets much warmer. And that's because this unit isn't a clever unit where it can take the energy from this cell and put it back into the source cell. It doesn't do that. So it dumps all the energy coming out of this cell that it's discharging into that heatsink. And that's why the heatsink is getting so hot. It's up to 55 degrees. When you're charging, it is taking energy from the source cell and putting it out to the destination cell. Well, of course, it does that using switch mode conversion techniques. And that's a reasonably efficient process. So the heatsink, when you're charging a cell, probably doesn't get that hot. It's when you're discharging a cell at these fairly considerable power levels. That's 25 watts. I mean, you can imagine how hot, well, you know how hot your 25 watt soldering iron gets. Well, that heat is being pumped into the heatsink inside this unit. And so that's going to need to be cooled down. And I'm trying to talk up to the point where this gets to 60 degrees because I know that at 60 degrees it turns the fan on. So let's just have a listen to that. 60 degrees. So there goes the fan. It's got variable speed. And yeah, it does go pretty fast. And now with that fan running, I think it's blowing out warm air at the back. You can see that the heatsink temperature is starting to come down. Right, let's do a charge now. So I want to stop this process. One thing I didn't mention is that while the charge or discharge function is actually underway, one thing you can change is the current. So if I bring this down to 0.5 amp or something, you can see that this will ramp the current down to 0.5 amp. So yes, you can change the current actually during the charge or discharge process. So let's stop that, disconnect this battery pack from the output, disconnect the input, and find something a bit bigger, because I actually want to charge this pack, because it actually says it's got a 5C quick charge, so we can charge this at up to 7.5 amps. Right, I've got this massive lead acid gel battery here, 12 volts, so it's right on the lower end of this voltage range, 12 to 40 volts. So let's plug that in. On this cable doesn't look like it's particularly high current, but it is very short. Let's just test this anti-spark function. Well, I did hear, oh yes, there are sparks there. Yeah, you can hear the crackling of sparks there. So I don't know whether the anti-spark function works on the input side. Maybe it's only set up to operate on the output side, but let's connect that on there. Okay, I'll rearrange this out a little bit and we'll start charging this cell. Right, let's plug this in. This is the 4S Lipo. Let's plug that in there. So we've immediately got a voltage for this. It's 15.1 volts. I can't remember whether that's fully charged or not. Let's put the balance connector in, which goes that way. I believe it's a bit short. Right, so there we can see all the voltages for this pack, 3.8. So this, I did a storage charge, so this is kind of half charged. Right, so let's have a look. What can we do with this? Now it's immediately sensed that it's a 4S, so I don't need to worry about that. Let's do, I don't know, 5 amps or something. So 5 amps. So it's a Lipo. We're going to 4.2 volts. Now you can change that target voltage a little bit. Again, we got a thumbs up at 4.2 volts. You can go down to 4.15 or 4.25. So a little bit of variability on that. We'll go for 4.2. Lipo 4.2, 4S, 5 amps. Now I can either come down to the start thing and press the center button, or I can just press that play thing and it will just get on and do it. So it's winding the current up, 2 amps, 3 amps. Now, of course, with this being, that's actually pulled the voltage of my lead acid battery so low, probably because of voltage drop in these cables, that it won't do it. It says input voltage is lower than 11.6. So actually, the input voltage can go down to 11.6 before it complains. So I'm not going to be able to charge this at 5 amps. I'm going to have to wind that down a bit. Let's come down to 3 amps maybe, and see if this lead acid battery can hold up at that current. 3 amps at 15 volts. Of course, it's going to be more like 4 amps on the input side, allowing for inefficiencies in the conversion circuitry inside. So Lipo 4.2, 4S, 3 amps. Let's go ahead and charge that. Now we can watch 3 screens here. The cell voltages. So yeah, that's got up to 3 amps now. We can look at the cell impedances. It hasn't worked them out yet. We can also look at the input voltage here. So it's down to 11.7, 11.6. So it's right on the limit. We're pulling 50 watts from this lead acid battery. Oh, it's just not going to do that, is it? Actually, I've got a second one of these. Maybe I'll put the two in series. Right, 2 of these lead acid packs, 12 volts, that would be 24 volts. I've got a 100 amp fuse, which I'm going to bolt across there, and then I'll derive my power from there. Let's do that. Right, let's clip this on. Negative on there, positive on here. Yeah, quite a spark came off there, so anti-spark doesn't appear to be on the input. Right, let's try that 5 amp charge. Now, of course, 5 amps at about 15 volts will mean that there's less than 5 amps at the 24 volts that's coming in, so that won't stress this connector too much. So let's go back up to 5 amps. Or 6 amps, why not? Yeah, let's do 6 amps. This thing does say it does a 5C quick charge. Well, 5 lots of 1500 is 7.5 amps. Let's do 6 amps charge. Lipo 4.2 4S 6 amps start and see how we get on. The current is running up, so that's got to 6 amps. Let's check the input voltage. 23.8. We're drawing 100 watts. 94 watts are going into this pack. Well, it says it can handle it, so that's fine. Let's check the voltages. Those are the impedances. They should appear at some point. 3.9 volts there. 15.6 is the total Lipo pack voltage. And these should start coming up. Right, so that's doing a charge, a balanced charge. So it's using its 2.2 amps per balance lead connector. Is that getting warm? Yeah, there is some warmth there, actually, a little bit of warmth. I don't know whether it's migrating out of the unit. No, I think the wires are actually getting warm. These wires won't, because this thing's rated for up to 65C discharge. That's an enormous current. But yeah, that seems to be hanging in there quite well. We've got cell impedances. 10.8, 11.2, 10.8, and 10.7 milliohms, and we got the input voltage 23.6, 101 watts, 94 watts going to the pack. Now you'll see that the temperature of the unit isn't rising particularly alarmingly, even though there's 100 watts running through it, and that's because, as I say, it's doing a relatively efficient switch mode conversion from here. Is that getting warm? Oh, that is getting a little bit warm. To here. So no, it's not going to have any problems with temperature rise on the inside of the unit. Okay, 3.93 volts across the board. So one thing that's notable at this reasonably high current is the milliamp hour indicator there is climbing quite rapidly. So this is a 1500 milliamp hour cell. It's not going to take long at that rate to get this one up to 4.2 volts. Now, interestingly, different from the little BG8S discharger balancer. Actually, it's not a discharger, it's a balancer and a USB port device, that thing I showed the other day. It showed when it was balancing cells by turning these little black numbered symbols a sort of terracotta color. This doesn't appear to do that, but let's wait until this thing gets closer to 4.2 volts. So that we can see what the balancing looks like at that higher voltage. Yeah, so this is quite a quick charge. We're up to 4 volts now on a couple of the cells after only, well, just under 5 minutes of charging. Still 6 amps, still got this milliamp hour counter racing up there. Let's wait till it gets a bit nearer to 4.2. Take a quick look at the temperature. It's got up to 43 degrees. As I say, although there is 100 watts of power transfer from the input to the output, not much of that is being lost in the electronics and therefore going into the heatsink. So the temperature rise of the heatsink is really quite slow. In fact, this does give you an input wattage 104 and an output wattage 97. So the implication there is that only 7 watts is being lost in the transfer process. Well, imagine a 7-watt soldering iron. It's not particularly hot. Take a while for that big lump of heatsink in there to warm up. And while this is running, we've got some updated cell impedance numbers. They seem to have dropped now. Do cell impedances drop as the voltage comes up? I don't know, but it's saying they're about 10 milliohms each. We're approaching 4.1 volts. Be very interested to see how this copes with balancing. Well, I suppose if it's balancing at 2 up to 2.2 amps per balance circuit. In order to hold balance, it's going to have to bring this current down for the last part of the charge. I mean, it will do that anyway because this is a constant current, constant voltage charge process. So it's constant current up to 4.2 volts, and then it will go into constant voltage so that it doesn't go over 2.4 volts, and the current will of course have to come down. So what I like about this is that you can see the current, you can see the pack voltage, you can see the individual cell voltages. You can, with 2 button presses, also see the voltage of the pack that's actually supplying power through the system. That I think is quite important. It'd be quite nice to see that on the front page, but that's nitpicking really because it's only 2 presses and we can see that. So back to this, just approaching 4.1. I was just interested to see whether this was getting warm at 6 amps. And there is a vague hint of warmth there, but I'm not alarmed by this, particularly as it says it can do a 5C quick charge. Well, it does seem to be able to handle it. 16.6 on the pack. We've done 840 milliamp hours of charge so far. We're getting close to 4.2 volts. Right, 4.19 volts across the board. Let's see whether this actually goes over 4.2. I did notice when I was playing with it yesterday that it does seem to go to, I don't know, 10 millivolts over, but that current now is starting to come down, 5.7. It's holding 4.2, the occasional blip to 4.21. The current is coming down. It does seem to have hit top with all the voltages the same on all the 4 cells. So it does look like it's able to balance at this fairly high current charge. I have to say, I'm quite impressed with the power to size ratio of this tiny 8-cell charger. Let's watch that current drift all the way down. It's still, of course, as the current comes down, the charge rate, the milliamp hour counter, is slowing down a little bit, down to just 3 amps now. It's holding these cells at 4.2, and well, I don't know if my initial charge was, or if my nominal charge is 6 amps, is it going to come down to 600 milliamps as the final current? It's hard to say really. Let's keep an eye on it. Now, is there a high-pitched squeal coming from this unit? Or is that just my tinnitus? It's hard to tell most of the time. I normally hear a high-pitched squeal pretty much constantly. Okay, that's coming down to 1.5 amps. We've got 1034. Now that won't go to 1500 milliamp hours because I started this pack at its storage voltage of 3.8 volts, not its minimum voltage of sort of 3, or as this unit says, 3.3 volts. So I was expecting that to go down to about 600 milliamp hours, which is a tenth of the nominal charge current of 6 amps, but it's not saying it's completed just yet. So yeah, this is pretty impressive. If you're charging in the field and you're charging from lead acid batteries, it does seem that because this thing complains at 11.6 volts, you're either going to need a very big 12 volt lead acid battery, or you're going to need to put 2 of them in series. So if you're charging from your car battery, it may be necessary to get an extra car battery, or have 2 cars possibly, and put the batteries in series to have enough power to do these aggressive quick charges. But yeah, it does seem to be entirely happy with 24 volts. Of course, it is 24 volts now because the current is so much less. Only 17 watts being drawn from the supply side, 14 watts going into the battery. Those numbers are changing constantly. The temperature never did actually get high enough for the fan to come on. The cell impedances are even lower now at the higher voltage. Is that a thing? I'm not quite sure. 4.2 volts across the board, down to 0.7 amps. Will it say that it's going to end the charge soon? Oh, it just beeped and I missed it because I was repositioning my camera to look at my bike battery, and it says fast charge done. And I seem to remember seeing this yesterday while I was charging, and then after a little while it's flashing the illumination behind this bit of printing on the front panel there. Fast charge done, and then a short while later, and there it goes, it says charge done. Now, to my mind, the fast charge is when the cells get up to 4.2 volts before the current starts coming down. So I'm not quite sure why it said fast charge done just a few seconds before it said charge done. That doesn't make a lot of sense to me. Right, so now it's saying charge is done. We can see the voltages here look like they're drifting a little bit up, if anything, and it does seem to still be putting 0.4 amps through this. I'm not quite sure why, and I'm not sure whether, even though it's saying charge done, why it still appears to be, well, beeping repeatedly, and the current now has dropped to 0, but every now and again it sort of seems to go up again. So I'm not sure whether this is a sort of holding current to keep it at 4.2. Is that a thing? So yeah, the big test, the thing I want to do is to use this T8 to charge this 8-cell Lipo 4, this lithium iron phosphate pack. The charger's still beeping, which is my electric bicycle pack. It's still got this unit. This is the iSDT BG8S, that's right, the battery balancer. Very good alignment between the cells. It did take about 3 or 4 days to get this cell properly balanced using this tiny balancer, but then it looks to me like this thing only balances at about 100 milliamps. I can stop that actually, about 100 milliamps per cell. So it just took an age, and this thing was sitting at about, I don't know, 50 or 60 milliamps a lot of the time. But I did eventually manage to get this thing balanced. But yeah, I'm very interested to see how the T8 copes with charging this battery fairly aggressively. Right, okay, well this thing is saying charge done and beeping annoyingly quite often. So I'm going to go into, I think I just did, let's come down to back. I think I did just stop it because it's now gone to the grey screen, and we can see that all the cells are at 4.2 volts. 16.8 is the pack voltage, which would be correct, isn't it? 4.2 times 4, and no current once we come out of the charge mode. So that was my first look at the brand new iSDT T8 8-cell battery charger. Actually, one or two things I probably should have said. Battery type can be lithium ion high voltage, lithium polymer, lithium iron phosphate, the Lipo, lead or nickel metal hydride, and NiCad, various quantities of cells on those chemistries. So yeah, as I say, that was my first look. Now I'm going to wait until these BattGo batteries turn up. I've got a couple of Charsoon BattGo batteries coming soon, and of course when you connect one of those on the output side, probably more relevantly, although it does have this 3-pin connector on the inside input side as well, then several more menus might pop up on this thing, and it might give more information. And similarly, that might be the case with this. If I can disconnect it, the little BG8S is also BattGo compatible. So if we connect one of these batteries with the XT60i connector, this should have a lot more functionality as well. So we'll come back to both these units when those batteries turn up. But for the moment, cheerio.